Hey, now that's a face I recognize.
Mister?
It's good to have a professional member of the media here, sir.
Right on time, too.
I know, perfect timing. One second, we round up the people that actually have this talk. Kind of important to have you here. Michelle. Oh, Carolyn, Houston. Thank you. Afternoon, everybody. How y'all doing today?
Very good.
Hey, my name is Jason Ryan. I'm the Communications Officer here at Earthrise Space Inc. We are the parent organization for Omega Envoy, a team that is, well, not a team, the team that is competing in the Google Lunar X Prize, and we are the Florida team as well. Earthrise Space Inc. is something special. We're comprised primarily from college students. Most of our team members are currently going to college, and they believe in STEM, and they believe in space exploration. That's what we're here to talk about today. We also are going to give you guys basically a brief overview of both ESI and Omega Envoy, and we got some very cool announcements to make. Today we're going to start off light and then build up a little bit to our 2 o'clock press conference. First, it's my pleasure to introduce Ruben Nunez. He's the Director and President of Earthrise Space Inc. To his right is Joseph Belaya. He's the COO. And to his right is Dylan. And Dylan, he is the Vice President. These are the men that are going to land a private rover built by college students on the surface of the moon. What we're going to do is they're going to come up, they're each going to speak a little bit about the company that's going on today. And then after that, after they sit down, we'll fill some questions from you guys. If you're with the media, and I see that there are some here, troublemakers that they are, please state your name, your affiliation, and go ahead and ask your question. With that, Ruben.
Thank you. Thank you very much, Jason, for introducing me. First and foremost, I'd like to thank everyone for coming to this open house. That was the goal, to get the community in here, observe what we're actually doing in-house, and share that with everyone. So, as Jason had mentioned, I am the president and one of the founders of Earthrise Space Incorporated, which is a nonprofit corporation dedicated to developing space technology in collaboration with academic institutions in the space industry. One of the reasons why we started the company was to compete in the Google Lunar X Prize. The Google Lunar X Prize, for those of you that don't know about it, is an international competition to land a rover safely on the lunar surface, travel 500 meters, and send data back. Such data will be HD video, several panoramic views of the surface, an email and a text message. And the first team in the competition to fulfill those goals wins a grand prize of $20 million, plus $5 million in bonus prizes. Of those $5 million in bonus prizes, we intend on pursuing the diversity prize. The team that has the most diversity, I believe we have quite a broad spectrum. We also intend on pursuing the long distance prize, which is to traverse 5 kilometers on the surface. And last but not least, the Lunar Heritage Prize, which is to approach one of the lunar hardwares that have landed on the moon before. Specifically, the one that we're targeting is Apollo 12. We will be landing about 2 kilometers away from Apollo 12, and then we will approach it and send pictures and HD video back of that location. The other thing that I wanted to talk about real quick as well was that ESI is highly involved with STEM education, as Jason had mentioned. Many college students participate in this company. We are currently partnered with the University of Central Florida, Embry-Riddle Aeronautical University, and the FIT. And there are many students that are from those universities, from different backgrounds and different engineering majors that are participating in the team. The main goal for that is to prepare them for the new space industry. We're pretty much building a workforce that will be working in such industry. And we are trying to partner with a lot of those companies, and we're trying to ask them, and we are asking them, well, what is it that you find? What is it that you're looking for in these students? So we can train them properly and advise them so that they're ready to either stay and work for us, which would be great, or move on into other major corporations and have those skills that they need. With that being said, I would like to make a couple of announcements. We have officially obtained our 501c3 status with the IRS, which is a big milestone. And this will help us obtain more funds through foundations and gain more donations and sponsors and partners. The next announcement that I would also like to make today for Earthrise Space Incorporated is that we have partnered with RAL Space, which is a UK firm. It's a space company over there, and they will be assisting us in developing the attitude control system for our mission. And part of that was that we also had to obtain licenses from the U.S. Department of State, and through those licenses, we are capable of working with foreign entities legally. We're one of the few companies that have that capability here in the United States that are part of the Google Lunar X Prize. And last but not least, the final announcement for Earthrise Space Incorporated is that we have partnered as well with Trelleborg Sealing Solutions. Trelleborg will be working with us and training us in several aspects of sealing certain components for our lunar rover and lunar lander. And we've already been working with them closely, and they are training our students in those applications as well. So if you have any questions, please feel free to ask. Thank you very much.
Members of the media that are here, if you do have a question, please raise your hand, state your name and your affiliation. Don't be shy.
I'm Jim Siegel. I'm with the Celebration Independent newspaper in Celebration.
Excellent. Welcome.
Forgive me for being a little bit late here. So could you just restate for my readers, what is it this company is going to be doing?
Okay, what we will be doing in this company is that the main goal is to have a lunar payload delivery service, which I did not mention. I apologize. We will be having a lunar payload delivery service that we will initiate through this first mission through the Google Lunar X Prize, through the Omega Onward project. We also intend on providing students with experience, with hands-on experience, by working for Earthrise Space Incorporated. Not just through the Google Lunar X Prize, but through other space projects as well.
Follow-up?
You know I have a lot of questions.
Love follow-up. Go ahead.
I've had practice. So who would you say your customers are? Who are your main customers?
Who are our main customers? Our main customer, Joe, would you like to actually answer that question?
Sure. So there's a number of different customers that we have. One customer is NASA. We have been awarded a contract from NASA, which is worth up to $10 million. You go after pieces of it, so we've been awarded a certain portion of that. There were only 6 teams in the competition that were awarded this contract from NASA. We are one of those 6. Since that time, 2 of those teams have merged, so now there's only 5 companies out there that can go after this money from NASA. They're interested, in this case, in obtaining data from our mission, learning how we we are doing this because we're doing this in a very innovative and new way. This is not the NASA typical way of designing and building spacecraft. So they want to learn from that and hopefully apply some of those teachings to how they do business. Other customers that we have, we'll be making an announcement later today at 2 o'clock regarding one of the other customers that we have, our newest customer. You can imagine that Ruben mentioned we'll be sending payloads to the moon, commercial payloads. There's a variety of customers that may be interested in flying payloads to the moon. There's very few people that are offering this capability. So it could be researchers, it could be governments, it could be industry players that want to send hardware to the moon. Or it could be also, for instance, people that want to fly their ashes to the, loved ones' ashes to the moon. Maybe a company wants to have their logo on the lunar surface for advertising, public relations type thing. So there's a variety of customers there. I think our third category of customer would be universities and industry players that are interested in going out and finding the talent they need and training that talent. If you go and you look at people that are hiring in the aerospace industry, they have a real shortage of recent graduates that have hands-on experience. And so we're very unique in that we're one of those few places where we're grabbing those university students while they're still in school, and we're providing them with that training and those skills that will make them very competitive as they go out into the aerospace job market.
So if I can just follow up.
Yeah.
So part of the workforce that you have in your company are these university students, and they're going to be working full or part-time for you or something like that. And by so doing, people are going to be trained, and then they're going to be presumably available for other companies who are looking for experienced people.
Correct. We'd like to keep the cream of the cream for our own internal use.
Okay, that was kind of my next question was, well, so you're going to have to then recruit more and train them again. So,
Right.
But some people are going to last and some people aren't, and the ones that aren't still have experience and they go off and do something else.
Exactly.
Great. And so to get these payloads to the moon or other places, you have to have delivery vehicles. So who's going to provide these vehicles? NASA or one of the commercial companies or China or whoever?
Well, so there, for our particular Google Lunar X Prize mission, we have 4 spacecraft that we're looking at having. This spacecraft stack will be launched on a launch vehicle. This is a service we're going to purchase from one of the providers out there, and we're in negotiations right now with several entities that may be able to provide us with the ride to orbit. Once we get to orbit, there is going to be a LOI stage, or I'm sorry, a TLI stage, translunar injection, which shoots us off to the moon. There will be an LOI stage, lunar orbit insertion, that will capture us into lunar orbit and begin our descent to the lunar surface. Then there is the lunar descent vehicle, the LDV, which you can see the beginnings of it. We have the frame assembled here, which we're going to be doing some structural testing on very shortly. And then within that will be housed our lunar rover, Sagan. So those are the 4 spacecraft that we're going to have to be building.
And would you hazard a guess as to when would we expect that Earthrise is going to be able to put something into lunar orbit, on the moon? About what time frame are we talking about?
Yeah, I can answer that question. By the end of 2014. We don't have a specific target date at the moment because we are negotiating with several companies, as Joe had mentioned.
Okay, that's fairly ambitious.
Yes.
And Joe, I have a follow-on with this question, which is the old way that we used to do at Kennedy Space Center to train the students was we'd have internships with Boeing, Lockheed Martin, anyone else, NASA, and you had all that flight hardware. Well, now that the shuttle's not launching, we don't have that flight hardware anymore. So the only way to do something is something like this company.
Okay. And what makes what you're doing unique from other people who are kind of doing this same kind of thing? I think you mentioned something unique or different or whatever, so what would that be?
No, you want. Well, I think what's unique about it is that, I mean, certainly there are industry internships, there are other aerospace projects out there that students can work on. Typically, if you talk to students that have gone through some of those internship programs, and I'm generalizing here, they're not all this way. Typically, these students are placed in what you could consider kind of menial roles. They're not given major responsibility. They're not challenged to really develop their skills and learn something, apply what they've learned in school in an aggressive way. When we have interns or hires, new hires, undergrad students, graduate students, that come and work in this company, they are given direct control over certain aspects of the project. For instance, we have a senior design group right now at UCF that is working on developing a new design for an antenna gimbal, and they are going to be developing that. We're going to go through our review process. We'll actually be fabricating and testing that in-house here. And so this is something that, you know, they get to really take control over that aspect of the project. And I don't see that really happening that much in other industry internship programs.
And roughly how many people would you expect to employ or be part of this after it kind of gets up and running?
Right now, I think our head count's floating around 40 people. About 30 of them, 30, 33, something like that, are students. About half in paid internships and half in unpaid internships. We will be continuing to staff up. I don't know exactly what the upper limit on that will be. It's going to depend upon our resources here and having enough chairs and tables for people to sit at, but we have been trying to engage as many students as we can.
Okay, thank you.
Welcome.
Jeff Suggert, WiredForSpace.com. Can you give us a little idea of the next 18 months, your key points you're going to try to hit? How do we know we're heading the right direction and
Exactly.
getting what we're expecting?
Exactly. Okay. So in the next 18 months.
Yeah, that's close enough.
All right. Perfect.
We're not going to go into 5 years or anything like
Yeah,
that.
exactly. Well, let me just give you a little bit of background. We've been working on this project since 2008, October 2008. A lot of development has gone through, but for the next 18 months, we will be doing a lot of advanced development work. We will be doing structural tests. We will be testing all of the electronics that we will be flying on our craft. Not just using those electronics, but we will also be using some development hardware provided from one of our sponsors in order to perform that work. Students and professionals will be working together on that. We will also be contacting the appropriate authorities in order to get clearance for the communication system for the mission, because that takes some time. We will be hopefully getting a spot on a launch by the beginning of next year, since we already started negotiating with a couple companies for a few months now. We're trying to get to that point, and as well, after next year, we should be building the final hardware January of 2014. So that's pretty much the scope of it.
So how many people in the organization are actually building, and how many people are doing all the other things about getting licensing? And just curious about how that breaks down.
I can answer that. That's fine. Okay, so typically what I do, I'm president and founder, of course, and CEO. I do a little bit of everything. I administer the team. I take care of the licensing at the moment as well. A little bit of project management, delegations. Most of the people that are full-time, that's pretty much what they do. For example, Joe does a lot of the contracting work, and then there's people that we also, like Dylan, that help out with the spacecraft design as well. He does most of that work, and he's managing that aspect of the project as well. The students are given a portion of those major components, and we give them deadlines, and we tell them what our requirements are. So, I mean, it's a little bit of everything. I even manufacture if we have to manufacture, right? If anyone has to do a little bit of something because we're missing a hand here and a hand there, everybody works and everybody helps each other. So, and that's the advantage of having a small company, because, I mean, we can work quickly, and we're so small, everybody knows what everyone's doing, and we do it very rapidly. So that's the advantage, and we really like how it's working, and hopefully, I mean, that's how it works out.
So you're gonna try to do with 100 people, what generally 5,000 or 6,000 people will be doing?
Well, and the reason that we can do that, some people call it the Iron Man effect, where the software capabilities have progressed so rapidly that it no longer takes buildings full of people in order to design spacecraft. The capability is so sophisticated now that a group of our size can tackle a project like this.
And you've got a lot of history to look back on.
Oh yeah, we're not reinventing the wheel here. We're trying to use as much heritage, hardware, and knowledge and expertise from the local space community as possible to make this a success.
Well, and to add on to that, Joe, as well, this is our core team here, about 40 people, but we are partnered with other space industry companies that are also working with us closely to develop such a mission. So if you view it from far away, our team is rather large. It's very large. I could say, with all the personnel from the other companies, it can be in the
150 people or so.
Yeah, 150 people or so. So it's not just us. It's also the consortium. You can consider us kind of a general contractor per se, because we work with all these companies together. Thank you.
Just to follow up on Jeff's question, so what kind of criteria are you using to choose applicants who want to work with Spacerise?
Well, I can answer that question. That's fine. Anyone that has a motivation to be able to do hands-on work and develop a product from its inception to its final stages. I mean, not a lot of people nowadays have the motivation to work hard and to accomplish goals. So, I mean, there's obviously an interview process, and we go through that, and we expect to have a lot of engineering students from different backgrounds, not just aerospace, but also mechanical, electrical, so on and so forth.
So these could be undergraduate students, not just graduate students?
No,
Yeah,
this
the vast majority of our students are undergraduate students.
undergraduate.
When we interview candidates, the most important thing is that the student have fire in their belly, that they really want to come here and work on this and have a passion for it, and assume a leadership role in pursuing it. The other thing that we look for is raw talent. Not necessarily that they have developed the skills or they have the experience, but that they have the potential. And that's really what we try to do, is we try to identify those individuals, pull them on board, and provide an environment where they can flourish, they can learn, they can grow, and they can help us be successful.
I saw some other hands out in the crowd. I'm not sure if you're with the media. Gentleman's right there, lecturer.
Marlon Mills, a student from UCF. What are some other projects that Earthrise Space are looking to work with in the future?
Sure. So we're going to be issuing a press release very shortly on another project that we want a grant on. So I won't go into many details on that. It is a aerospace device that's going to fly on an aircraft and perform a science mission. So this is something that we're going to be announcing shortly. We're going to be designing and building in-house and then actually flying on the aircraft. We also have partnered with a number of various entities here in the state of Florida to pursue several other grant opportunities. Basically anything either space or aerospace related, we're looking to pursue. And there's a lot of opportunities out there, especially for small levels of funding, $50,000, $100,000. I mean, that can go a long way in a company like this, and we can engage quite a few students.
And I believe there was another lady that had her hand up, or the gentleman in the back.
My name's Mike Berger, I'm a UCF alum. You mentioned the trans-lunar stage and the lunar orbit injection. Are these UCF students or students developing those stages and doing the orbital mechanics involved to actually do the landing, get from here to there?
In terms of the orbital mechanics, yes, we have 2 different UCF students that are using a software package called SDK, Satellite Toolkit.
That was provided to the GLXP teams around for their competition to help us fulfill that goal.
So yeah, so we're doing all of that work here. Jeff Mitchell in the back there. Jeff, raise your hand real quick. FIT professor and with some experience in this area, he's been advising. And then in terms of the spacecraft, some aspects of the spacecraft will be outsourced. Most of it will be done in-house here by our students. In the case of the TLI stage, it's essentially just a solid rocket motor. We're not going to be pouring rocket casing and all of that here. We're going to outsource that. We would definitely do all of the integration and the testing. And certain other components we're going to purchase off the shelf, the tanks, thrusters, various items. But the vast majority of the work will be done by our students here.
So the landing weight of the first lander, how many pounds are we talking about?
Bill?
In moon pounds.
Typically we're designed for orbital mechanics maneuvers, we usually talk in NASA units, so I'm going to go with those numbers because I know them a little better. Essentially, we're looking to pretty much land a little over 100 kilograms on the surface, and that's fully loaded with propellant and payload. Obviously, the overall payload stack-up's going to weigh quite a bit more to get us all the way from something like LEO or GEO all the way to doing the actual insertion maneuvers, power descent, and getting to the surface. But this vehicle right here will be doing about 10-20% of the power descent necessary to take us from lunar orbit down to the ground. And it's going to be very advanced. It's going to have hazard avoidance systems on board and really good processing capabilities as well. We're using a lot of reliable technology for the propulsive maneuvers, things that will kind of help us guarantee that we're going to get to the ground safely and make sure our sensitive payloads are going to stay intact.
Nelson Quesada, Freedom Middle School. If the company were to win this competition, what exactly would you be spending your $20 million on?
Ruben, you want to answer that?
Well, I'm going to take that $20 million and buy me a couple houses. No, I'm kidding. So what's going to happen is we intend on expanding the company with that money. We intend on doing more lunar payload delivery missions. That is the intention. Hire more experts, hire more interns, give more people the chance to actually work on lunar missions and other missions that we might also encounter in the future. So that's what we would do with that money. We want to continue working and provide jobs.
I mean, we're looking at providing a regularly scheduled lunar delivery service.
Mm-hmm.
So our initial target is once every 2 years, there'll be a mission to the moon. And if you want to go, if you're willing to pay the price, we'll be willing to fly you to the moon. Obviously, if the demand is there, then we'll fly more often than that.
I believe we got a question from one of our student members in the back. Please state your name.
We're not going freedom break, so it's like Freedom Middle School. I have a question. Do you think in the possible future you might do payload missions to Mars?
That's a Joe question. That's a you question. You're the Mars person. I'm not the Mars. You're the Mars person.
So, in one of my other ventures, I have been working on concepts and designs with a team of engineers for settlements and infrastructure for the surface of Mars for human exploration. I would love for us to get to the point where we have the capability and we have the experience to be able to do a Mars mission. That's not on the books right now, but believe me, if I see the opportunity, then we're going to go after it.
And in answer to his question, it's 37 pounds on the moon.
Well, that's important for all the things that, structural stuff.
I believe the young lady, Tess Baxter, in the back.
I'm an aerospace ex-NASA employee, but I'm not here for the open house. Forgive me if you've answered this question, but your integration testing, there's only a certain amount you're going to be able to do here.
Of course, yes.
Where will it be done? outside?
We've partnered with a company called GEMS, that's based here in Orlando and has a great deal of experience and capability in that area. I believe they're working right now with Orbital Sciences on their vehicles, so they will be assisting us in that area.
Thanks.
I believe I saw another hand over here, gentleman right there.
How much will your payload weigh, and commercially, how much will you be able to put on the moon? And then what sort of launch vehicle are you aiming to get, and how much do you think it would cost to commercially send whatever I want in space?
Let me try to remember all those questions.
You want to take one at a time and then maybe do
Yeah,
follow-ups?
let's do one at a time. So I think your first question was,
What's your maximum payload weight?
We're looking at landing about 20 kilograms, carrying 20 kilograms to the surface right now.
and of that, about 12 to 15 kilograms would be our rover, our primary payload, and then the additional 5 kilograms would be for commercial customers.
And what kind of launch vehicle are you looking to use?
We are, as I had mentioned earlier, we're looking at different options right now. We're speaking with a couple companies that I cannot mention at the time right now. But we would like to actually launch from Florida, because there is a bonus prize as well that I probably did not mention earlier, that if any of the teams launch from the state of Florida as part of the Google Lunar X Prize, they will provide such a team $2 million in bonus prize. So that is our intention. And we're the Florida team. Why not? We have to launch from here, right? So that's our main goal.
And how much do you think it would cost to commercially send something to space? Like if I came to you and said I wanted to put something up there, how much would it cost?
Well, I don't think we've priced out just sending it to someplace before the moon. But in terms of actually getting something to the lunar surface, we have advertised our rates for that. The price is $1.6 million per kilogram on the lander. And then if you need mobility, if you're a scientific instrument or something that you want to be on our rover, that's $1.8 million per kilogram.
Thank you.
Anybody else got any questions? Short stories? Up, right there.
I have a question. My name is Barbara. I just work on the other side of that door, so.
Welcome. Great.
Thank you, but I've always loved moon stuff anyway. I was just curious, are you doing all your development work in this building?
Yes,
Okay.
we are doing.
Vast
We're in
majority of
that
it.
area back over there.
Correct. The vast majority, yes.
Just wondering.
I'd like to consider that too. We're doing a lot of development here in-house, as much as we can, within the limitations of being in an indoor facility. At some point, we'll be looking within the next 18 months or so to be doing real propulsive demonstrations, and obviously that will take place somewhere way outside.
We won't be firing off rocket motors here in the park. No worries.
Jim?
Just a follow-up to the comment that you had about the amount of money that you will charge per kilogram, $1.6 million. So just to put that into perspective for my readers, how does that compare to what NASA or other people charge today, or how much it costs to put a certain thing, say, on the moon or in lunar orbit or some orbit, or the ISS or something like that?
Well, I can give you one point of reference at least, and maybe Ruby can give you some others, but we're, I believe, it's either 10 or 20% less expensive than our fellow Google Lunar X Prize competitors. And you have to remember, there aren't that many entities out there that are providing this service, or talking about providing this service, so.
That's pretty much it. I mean, no other government that I am aware of. I don't know of any other government entities or space agency that is providing a lunar payload delivery service.
Okay. Incidentally, this is lunar payload delivery and not, say, to the ISS or some asteroid or something. It's lunar right now.
Strictly the moon.
Of course, the capability that we will have developed, not that particular spacecraft, but the ability to go through this process and execute, we do intend to apply that to other projects. So whether that be going to Mars, going back to the moon, going to an asteroid, doing other things in space, We will have a key set of infrastructure, a knowledge base, an experience base that we can apply to those other projects.
Maybe you mentioned this earlier, but this is going to be a reusable spacecraft.
Reusable in the sense that the design is reusable. Once we have achieved the mission and proven out the hardware, then we have flight heritage. And so we may make some incremental improvements to the vehicle, but we would probably not, unless we were talking about sending a much larger payload, probably not change the design too much. The idea is that you've gone through, you've tested it out, use it again. Your customers can have high confidence in the system because it's proven. What was the rest of your question?
What I meant was
It's also going to be very scalable.
the vehicle itself is coming back to Earth?
No, this is a one-way.
Okay.
One-way ticket.
Yeah, that's the, you know, people have asked, are you going to bring back some rocks? And those are not requirements of the Google Lunar X Prize. And something that you learn in engineering is KISS, keep it simple, stupid. So let's not add any additional requirements that are, it's going to make our challenge more difficult.
I understand.
Now, if there is a customer that would most likely likes for us to bring something back from the surface, we can discuss that further in future missions. That's possible as well. But of course, that customer must provide the funds in order to accomplish that.
I understand.
One of our students right here.
You mentioned that the cost of reprint is 30% cheaper than other companies. Why is that?
10 to 20%, something like that.
But why is that? Like, why would you have cheaper? Why would it be cheaper?
That's
Well,
a very good question.
That is a very good question.
We're trying to, as in most things in life, you have people that work with you, collaborators, and you have competitors. And so we're not the only entity out there that's looking to go to the moon. We want to encourage and provide enticement for those customers to come and sign up with us as opposed to with one of our competitors. We can charge these lower rates because our cost structure is significantly lower than the companies out there that are hiring all senior engineers with decades of experience. Because we're making use of our student labor pool here, we're able to keep our costs low.
Correct. And we're also nonprofit.
Right. Which is what 501c3 is. We're going to have time for about 2 more questions, and then we got to wrap before we get ready for the next press conference. Gentleman back there.
Yes, Andrew Schroeder from the University of Florida. You mentioned that you'd like to have the launch or the mission occur sometime towards the end of 2014, but from now until then, which is approximately 2 years, can you give us any idea of the timeline of where you think each of your phases are going to be? Like when you think you're going to be moving into testing the lander versus the payloads versus the integrated system, things like that?
Okay, so in terms of schedule, we're pretty much looking to, again, 18 months is a good number that was mentioned earlier. That's really when we're looking to pretty much have an integrated vehicle. You know, we can demonstrate, push through a qualification program, and be ready for flight. There are requirements based on whatever launch vehicle we're going with or providers that we have to be ready at such and such time ahead of time before schedule. Some of that will be dictated by launch schedule itself. But we're pretty much looking at in 18 months to having fairly well assembled vehicle that's mostly through the way of its qualification program, that's for sure.
And we'll be starting, I mean, we have ongoing test program right now. We've been doing extensive testing on the lander's suspension system. We are geared up now. We've just assembled this prototype. We're going to be doing some drop testing of this. And really, these are the core tests to prove out the structure, allow us to move to the next stages of vehicle integration and testing.
Another thing I want to point out is that we're actually taking an approach of a really rapid development approach, I guess you could say. Trying to prototype things fast, test things fast, get results fast, and be able to evolve the technology in parallel with all that at the same time. And that's going to be an overall benefit in terms of schedule.
I believe the young lady in the corner, beautiful. Oh, she's looking behind her. Call her out. It wasn't even her. I'm sorry. Does anyone else have any further questions? We've got time for one more. Going once, going twice, sold America. With that, folks, we're going to conclude today's press conference to get ready for the second one, which will start promptly at 2 o'clock. If you guys want to hear something really cool and really awesome, you really need to be here for that one. Again, we starting at 2, and we hope to see you all there.
Thank you.
Thank you.